Unit 4 review. First question asked is number 11, which I did already go over in my other class. So here it is, worked out, but I'm going to walk you through it. So it says in the diagram, A is a midpoint. So I mark it with tick marks on both sides. A is the midpoint. The B is the midpoint of UW and C is the midpoint of VW. So I've marked all the tick marks according to what they told me. And then they're asking for the length of CW, which is half of this bottom side of the triangle. Okay. Now, the way that I'm going to have to solve this is I have to remember mid segments are these segments that connect midpoints. Okay. So A to B, that's a mid segment. And a mid segment is half of the side that it's parallel to. Okay. They're parallel to the third side of the triangle that they don't intersect. So AB is half of BW, or BW is twice AB. You could use either of these to set it up. I circled the one I'm using. I like to multiply by 2 rather than half. So I'm going to set up VW is twice AB. So in blue, my expression down here is VW, which they said is 5x plus 19, is twice AB, which is 3x minus 7. Then you can see my algebra to solve for x. Okay, I had to distribute, then move x's to the one side, constants to the other. I got x is 33. That is not our answer. The question did not say solve for x, bless you. It said to find the length of CW. So I'm going to have to take that 33 and plug it back into my expression for VW. So 5 times 33 plus 19 is 184. Bless you. Now that's the entire side length. They asked for CW, which is half. So I divided it by 2 and got 92. Now, that's not the only way I could have found CW. I had to find X, but once you know X, if you understand that CW is congruent to AB, you could have plugged that 33 back in up here and done 3 times 33 minus 7, and that also would have given you 92. Okay, all 3 of these pieces that I put 3 tick marks on are 92. Does that make sense? Okay, if you want to go ahead and look at number 12 while I've got this screen up here, this is the one that used the exterior angle theorem. It said the exterior angle of a triangle is equal to the sum of the opposite 2 interior. So I set that up as 103 is the sum of those 2 angles. And then it's a quadratic, so I got it set equal to 0, moved everything to the side. Standard form quadratic, I factored, split, and solved. And when I solved, one of these answers, -6, does not make sense when you plug it back in. Because if I plug in a negative up here, I end up with a negative angle in my triangle, which does not make sense in the context of the problem. So I know that can't be the solution. But when I plug in the 3 to both of these, it works and gives me a normal angle measure that could be, and it checks out because those 2 do indeed add to 103. If you forget the exterior angle sum or the exterior angle theorem, you could have done linear pair to get this angle of 77 and then set up the sum of all 3 equal to 180 and then done the same thing from there to get it set equal to 0. Yeah. We good? All right, who else has a question besides 11 or 12? Any?
Number 1.
Number 1? All right, on number 1, you are told to find X. They have in the image QS marked as perpendicular to this bottom side. So that means, what is US? It doesn't ask this, but I want you to know. What type of segment would this, or not US, QS? What is this segment if it goes from a vertex to the opposite side and makes a 90-degree angle? It is perpendicular because of the 90-degree angle. You cannot tell me that it's the bisector, though, because they didn't mark these 2 congruent, and so I can't assume that. But what else could it be if it is perpendicular from the opposite vertex
Altitude?
Altitude, good. So that is an altitude. So I know this question didn't ask it, but it's good to know what your special segments are. So this is an altitude, meaning it makes a 90-degree angle. So that creates two right triangles, okay? And this right triangle on the right side has two of the angles labeled in terms of x. So 3x is this top angle and 12x plus 15 is the bottom. Now, what I know about right triangles is that the two acute angles have to be complementary because 90 degrees is used up by the right angle. So there's only 90 degrees left for the whole triangle, correct? So you can set it up as 3x plus 12x plus 15. So the sum of the two acute angles has to add to 90. That's what complementary means. They add to 90. If you did not remember that the acute angles of a right triangle are complementary, you could have set this up with all three of these added together. So the 3x plus 12x plus 15 plus 90 would equal what? 180. That's fine. That gets you the same thing. It just has like maybe an extra step. Okay, so either way, whether you did all three added together equal to 180, or you did the two acute angles added together to equal 90, you're going to have to solve for x. So on the left side, I have like terms that I'm going to combine. So I get 15x plus 15 equals 90. And then I'm moving my constant to the other side because there's only one x term here. I'm not going to move x's. So I'm left with 15x equals 75. And then I divide out my coefficient. What I do to one side, I do to the other. And what does that give me? Did the question ask to find x? It did. It actually did. A lot of times it doesn't. They want you to take it a step further and find a missing angle, and you would plug it back in. But this one simply said find x, so we can stop. We're done. Now, could I plug x in here to check my answer? Yeah, and that's not a bad idea, especially if you'll get Desmos Scientific. You can plug that in and have it calculate really quickly, okay? Or some of you can do that in your head really quickly, okay? The 3 times 15 is 45, and the 12 times 15 plus 15, or sorry, I don't know why I said 15. The 12 times 5 plus 15 is 75, and the 3 times 5 is 15. So if you plug them back in, you get 15 and 75. And do 15 and 75 add to 90? They do. So you can kind of check as you go with those. What else? Ian? 25? All right, 25 is, it says, what statement could prove that XY is the perpendicular bisector of AB? And then they have multiple choice. Okay, what we learned about perpendicular bisectors is that 1, they're perpendicular, meaning they make the 90-degree angle, and 2, they bisect the segment. So this has to be cutting, if it's a bisector of AB, then AD is congruent to DB, right? And so D is the midpoint. So we'll read what the choices say here. Okay, so any point plotted along AB is equidistant from both points X and D. So if I put a point, let's say here, they're saying that that would be equidistant from X and D. So would that point to D be the same distance as that point to X? No, that one doesn't make sense. Okay, any point plotted, let me get rid of that point. Any point plotted along AB, so I guess I could have left that point. I could have used any point plotted on AB, let's put it here this time, is equidistant to B and D. So is this black point the same distance to D as it is to B? From this point that I added to D versus this point that I added to B, are those the same distance? That one doesn't make sense either. Okay, those are all on the same segment. And so this is definitely closer to D than it is to B, because D is between it and B. Okay, so that one doesn't make sense either. Okay, any point plotted along XD is equidistant to A and B. So if I plot a point here between X and D, will it be equidistant to A and to B? That one makes sense. And now, not only does it look like it makes sense, the perpendicular bisector theorem tells us that if you have a perpendicular bisector, any point on the perpendicular bisector, so it could be anywhere on this vertical line here, is going to be the same distance from the endpoints of the segment that it bisected, which in this case is AB. So any point that you put on here, so that includes the X, the D, the Y, and any other location on this line, is going to be equidistant from A and from B. Okay, that's what the perpendicular bisector theorem told us. So yes, that one makes sense. Okay, and just to clarify, the last one says any point plotted along XD is equidistant from A and D. That one doesn't make sense. That would mean that they're telling us this distance here is the same as this distance here. And that absolutely does not make sense, because we know this is a right angle. And in a right triangle, the hypotenuse has to be longer than the legs, right? So we know that one doesn't make sense either. Okay, but what you really had to understand is the perpendicular bisector theorem that says any point on the perpendicular bisector is equidistant from the endpoints of the segment it bisected. Now that's actually one of the topics that I made y'all supplemental notes, and I'm going to hand them, after we're done going over review questions, I'm going to hand them out to you. But let me show you really quickly. They are here in our Canvas. If you go to modules or go to My Learning, in the Unit 4 module here at the bottom, under the review, I added a supplemental note. Okay, and this is a blank copy of it. I'm going to pass out a blank hard copy to you in just a few minutes. Okay, this is just some add-on notes of things I have noticed a lot of questions about. So it's like when there's lots of overlapping segments, or perpendicular bisector was on there. And then I don't have time in class to go over these additional notes. These are things we have talked about. They use theorems and rules that we've been using all year, but sometimes y'all are struggling to apply them to different situations. And so this is just an add-on notes that you may want to take a look at tonight and try. And then I've already made a video of the front side of it. I made that this morning and posted it. And then I'll make a video of the back side. It's a single page, front and back. And I'll add the video of the back side of it here. And y'all can watch those as extra ways to study or prep for the test tomorrow as well. Okay, so that perpendicular bisector question, that one that was just asked about, that's one that I cover in that supplemental notes again. Is that perpendicular bisector theorem. All right, what else?
Number 11.
I already went over number 11. It's the first one I went over. What number is that?
11. So like it's a
Oh, I don't, yeah, the numbering's off. Is this the 11 you're talking about, Vinny?
Oh, yeah, that one.
Okay, my bad. I don't know why the numbering's off. That should be number 26. Okay, but yeah, because we go from 25 to 11 to 27. Weird. All right, so let's look at this one. It says 11. I don't know why, but find this one on yours. Okay, guys, I need those side conversations to go back to a whisper, please. All right, what type of triangle do you see here? What part of the triangle is congruent? Two of the sides, so it's isosceles. I heard somebody say it. Okay, if you have two sides congruent, you have an isosceles triangle. And what you need to remember about isosceles triangles are that the legs are these sides that are congruent, What's the third side called? We have two legs and a base. So the base runs along here. This one happens to be sitting on its base, but they do not have to be sitting on its base. It's not called a base because it's what it sits on. This could be turned upside down and it would still be called the base, right? So it's just the third side that's not congruent to the legs. So you have two legs and a base. Now the base connects the base angles, and the base angles are congruent to each other. So these two angles are congruent. So far, so good? So that means that this must also be 47, right? So then the angle where the legs meet, this is called the vertex angle. The vertex angle is the one that's not congruent to the base angles. But if I know 47 and 47, can I find the vertex angle? Yes, I'm going to take 180 minus 47 minus 47, or you could add the two 47s together first if you prefer, and then subtract that from 180. Either way, you get 86 for the vertex angle. Are we good? Now that I know the vertex angle here, this angle that's marked with an expression in terms of x, what's the relationship between that vertex angle and that angle that has the x in it? That's a linear pair. So we know that these two together should add to 180. So I'm going to set that up as an equation. I'm going to say, okay, 8x plus 6 plus 86 must equal 180 because of the linear pair relationship. They are supplementary. They add to 180. So now I'm going to combine like terms. So my 6 and 86, I've got 8x plus 92 equals 180. And then I will move my constant by opposite operation. So I'll be left with 8x equals what? 88. And then I divide out the coefficient of 8. So x is 11. I go back and read my question. What is the question asking for? The value of x. So I am done. I have found the value of x. Now, could I plug that back in and check my answer? Absolutely. If I do 8 times 11 plus 6, that's 94. So this angle would be 94. 94 plus 86 does indeed equal 180. We feel okay about that one? You had to know about isosceles triangles to do that. You had to know isosceles triangles and linear pair. All right, what else we got? Any other questions on the whole review? 28 and 29? Okay, so that last page, guys, the conversations, bring them down to whispers. Remember, I'm recording. All right, on 28 and 29, this last page, you will have questions in this format on the test where you're trying, it says what a student did or said, and you're trying to just say where the student's error is or if they were correct. Okay, so in 28, and they don't give a picture. If they don't give a picture, what should you do?
Be smart.
Be smart and draw a picture. Okay. So I'm going to draw a triangle LMN so I can label things that they tell me. So it says in triangle LMN, and it doesn't matter which you label. I could have done L at the top and what, it doesn't matter. So, and it's not going to be drawn to scale. So we just draw our triangle. It says MP bisects angle LMN. So LMN is here. So this angle is bisected. What does that mean? Cut in half. So that I need to draw an angle bisector, cutting that angle in half. Okay. So I'm going to put congruent markings that show this angle is now congruent to this angle. Okay, so in that says it's called MP. So this point is P. So ray MP bisects LMN. So y'all agree with how I've drawn it? Okay, now it tells us that LMP, so LMP, that's this smaller one at the bottom, is 3x plus 5. And PMN, so that's the smaller one at the top of the bisected angle, is 5x minus 3. What do we know about those two angles that we just labeled? They're congruent, okay? They are the two congruent angles that were created when the big angle was bisected. So congruent means what? Congruent means the same, equal. So I'm going to write an equation setting them equal. So it should be 3x plus 5 equals 5x minus 3, or vice versa. It doesn't matter which one you put on the left and right. So let's see what the kid said. The student said, since MP is an angle bisector, the two halves add up to 90 degrees. Is that true? Does that happen if an angle is bisected? Does that mean these two little ones have to add to 90? No, we were not told that NML is 90 degrees. We cannot assume that. We weren't told that these were perpendicular, that there was a right angle, nothing of the such. So we cannot assume that those two halves add to 90 because a bisector always splits an angle into right angles. No, that is not what an angle bisector does. Okay, so he set it up saying that the two smaller angles should add to 90 and solve to get this, but we know that that's wrong because that's not what an angle bisector does. So the answer choices say the student was correct. Absolutely not. The student confused angle bisector with altitude. Does an altitude split an angle into two right angles? It creates two right angles, but it doesn't divide the angle of the triangle into two right angles, right? Okay, so it's not dividing the vertex angle of a triangle into two equal parts. That's not true either. Okay, the student subtracted instead of adding. No, they didn't just make a mistake in solving. They made a mistake in their setup. So this last one says the student needed to find angle N instead of LMN. Yeah, that's wrong too. Okay, so none of those, which describes the student's errors. Let's read this again. Let me go back and read this altitude. The student confused angle bisector with altitude. Oh, this says the bisector divide. I read that as he said the altitude divides. Okay, so this says the bisector divides an angle. That's true. That's my bad. I didn't read that clearly. The bisector divides an angle into two equal parts, not into right angles. So that technique, the way, I don't like the way that first part is written, but that's the one. Okay, because it should be an angle bisector. Okay, it is not an altitude. I still don't think he confused it as an altitude, but this is the best choice there. Okay, it should have been an angle bisector. They should have been set equal to equal parts. All right, 29, the one right under that. Again, no pictures given, so I'm going to draw a picture to make sure we understand what they're telling us. They say in triangle ABC, so in triangle ABC here, they tell us that DE is a mid-segment connecting the midpoints of AB and AC. Okay, the midpoints of AB, so put a midpoint on AB and a midpoint on AC, and they are connected That's the mid-segment. And they say that it's called DE. So I'm going to label those points D and E. So far, so good? Now the student said, since DE connects two sides, it must equal the third side. So he's saying that the length of DE is equal to the length of CB. Oh, and we didn't label our equations on here. Let me label those. Says that DE is 3x minus 5. And BC is 6x plus 2. So what the student did was set those equal to each other. Are those equal lengths? No. What's the relationship supposed to be? DE is half of CB, or CB is double DE. They are not equal to each other. Okay, so his mistake, he's definitely not correct. The student forgot that a mid-segment is half the length of the third side. So the correct equation should be that 3x minus 5 is half of 6x plus 2. That's it. Okay, the student confused the mid-segment with a median. No. A median connects a vertex to a midpoint. That's not what this is. And the student used subtraction and no, they didn't make a mistake in their solving. They made a mistake in their setup. Okay, we feel okay about that? I'm going to add here that DE, because it's a mid-segment, is half of BC or CB, however you want to word that. So that is what this equation says right here. Are we good? All right, so finding mistakes in other people's setup and work. That was what those two were seeing if you could do. Draw a picture if a picture's not given. Gracie?
Maybe 5.
5? Yeah.
Do you have a black shirt that I need to?
Yeah. All right, number 5. C is already done here. I did that in another class, so you can look at that if you want to. In number 5, it says find X and Z if the line in the center of the triangle is a mid-segment. So they didn't label it, but they told us it's a mid-segment. Yes. So this is a mid-segment, meaning that this is a midpoint. So that these must be equal to each other, right? So to find Z, I know that these two expressions in terms of Z must be equal. So 3Z equals Z plus 22. So then I'm going to get the Z's to the same side. Divide out the coefficient. So I get Z equals 11. Did they ask us to find Z? Yes, that was one of the questions, but it's only part of it. We also have to find X. So now if they told us again that this is a mid-segment is half the length of the side it's parallel to, correct? So that means that 8x minus 2 is double 2x plus 1. Or you could set it up 2x plus 1 is half of 8x minus 2. Both of those will work if you do the algebra correctly. So I'm going to distribute, and I get 4x plus 2. Now I need to get my coefficient, or my x's to the same side, my variables. And my constants to the other. And then divide out the coefficient. So x is 1. Now, what could I do to check these? Yeah, for the z and for the x. If I plug these back in, if I plug in x is 1, what is 8 times 1 minus 2? Yeah, it's gonna be just 8 minus 2, so that's gonna be 6. And then 2 times 1 is 2, plus 1 is 3. Does that check out? Is the mid segment half the length of the side? Yeah, so we got X right. Now, if we wanted to check Z, if I plugged in Z as 11, I would get 33 for this side. And then 33 for this side. And they're supposed to be equal, right? Okay. They're supposed to be equal, so that checks out. If you have the time to check your answers, okay, can never hurt. It can only help you to check those answers and see if it checks out. Yeah. 4? Mm-hmm. I can do 4. All right, so in number 4, we are told that KM, so that's on my, I know yours is in black and white, but on mine, that's this red segment. So KM is the red segment here. It is a median. A median connects a vertex to the midpoint of the opposite side. That is not marked in here. You have to know the vocabulary median. So K is a vertex, M is the midpoint, so that means that these must be congruent. Okay, so now it's guys, the math on this, a lot of these actually isn't difficult. It's knowing the vocabulary. So if you know what a median is, then you know that LM is congruent or equal to MN. And then you can set up your equation because they tell us LM, please stop, is 4x minus 9 and MN is 2x plus 11. So then it's just a basic algebra problem and we're going to move x's, oops, I don't know what just happened. Go back to that. We're going to move x's to one side. And constants to the other. Divide out your coefficient. Now, did the question ask for x? Here's the other place people are going to make this. So you have to know median. You have to know what a median is to know that these are equal. Then you have to read carefully. They do not say solve for x or find x. It says find the length of LM. So now I have to take this back to find LM. That's this one right here. 4x minus 9. So now I'm going to plug in 10 for x. So that's 40 minus 9 is 31. Now, I could also plug that x into the other expression just to confirm. 10 times 2 would be 20 plus 11. That's 31. Was it supposed to come out the same? It was. So that confirms that we found x correctly. That's indeed 31. If they asked for LN, you would have to double it. That'd be 62. So pay attention and read carefully what is being asked. That's a really common place y'all are going to mess up or did mess up on the quiz and might mess up on the test. I hope not. I hope I've reiterated it enough to read the question again when you think you're done. What else? Any others? We're all good? Done? Okay, I'm going to stop this video here and I'm going to pass y'all out that supplemental notes I talked about.